Hello, and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson number 4 on the distributive property. Before we begin, let me remind you that a worksheet for this lesson and a homework set can be found by clicking on the video's description. As well, don't forget at the top of every at the top of every worksheet, we have a QR code that can be scanned using either a smartphone or a tablet to bring you right to this video. All right, let's begin. In the last lesson, we talked about the associative and commutative properties of addition and multiplication, and they were quite separate. We had the commutative property for addition, and then the commutative property for multiplication, the associative property for addition, and the associative property for multiplication. Today, we look at the last of the big three, the distributive property. All right? So, let's take a look at exercise number 1. It says, consider the product 4 times 15. Evaluate using the standard algorithm. All right, now, depending, it may have been a little while since you've seen this, but let's do 4 times 15. All right, the standard algorithm is that we first do 4 times 5, and we get 20. All right, we write down the 0, and we put a little 2 up here. Then we do 4 times 1, which is 4, and then we add the 2, and we get 6. So we get a final result of 60. Now you may understand why that algorithm works, or you may not, right? But it does work. But now what we're going to do is we're going to think about multiplying 15 by 4 in a little bit of a different way. Obviously, 15 is the same as 10 plus 5. So really, 4 times 15 is the same as 10 plus 5, another 10 plus 5, another 10 plus 5, and another 10 plus 5, right? So obviously what we get is we get 40 here, and we get 20 here. Adding them together, we get 60. So what have we really done? We've really said that 4 times 15 can be thought of as 4 times 10 plus 4 times 5, right? And that's known as the distributive property of multiplication over addition. The distributive property of multiplication over addition. Meaning that when you multiply two numbers together, you can break one of those numbers apart and multiply each of those parts and then do the addition. 10 and 5 are just convenient. I mean, we could do 4 times 15 in a variety of ways. Watch this. We could look at 15 as being 11 plus 4, right? That would then say, well, I could do the 11 times 4 and the 4 times 4. I like 10 and 5 more, but it still works. Here we'd get 44, here we'd get 16, and 44 plus 16 is again 60. All right? It even works with subtraction. Watch this. Let's say I did 4 times 20 minus 5, right? That's the same as 15. So 4 times 20 minus 4 times 5 would give me 80 minus 20, and that would also give me 60. Hoo-hoo! Isn't that cool? I love the distributive property. It's one of the many ways that I'll do multiplication in my head when push comes to shove, especially when I'm doing something that I find a little bit hard, like 4 times 19 in my head, or something like that. You know, 19 is an unfortunate number, so I just think about 19 as 20 minus 1. And then I can multiply the 20, I can multiply the 1, and then I can subtract, right? So let's play around a little bit more with the distributive property, but purely numerical. No variables yet, okay? I'm going to scrub out the text, so write down anything you need to. All right, here we go. Let's move on. Let's talk about the distributive property. All right, the distributive property says if we're going to multiply A by B plus C, and this could also be subtraction, then what the distributive property says is that I can multiply each part of this particular number or this particular expression by A and then do the addition second. So normal order of operations would insist that we add these two numbers together first because they're in the parentheses, all right, and then multiply. The distributive property says we can do the multiplication first, then add each component part. All right, so let's take a look at how that works numerically. Okay, evaluate each product by using the distributive property to make it easier. On B, express 18 as a subtraction. Do not use a calculator. Again, anybody could do this. I have a 9-year-old son, Max. I have a 6-year-old daughter, Evie. Either one of them could do these problems using a calculator. So what I'm asking you to do is be better than a 4th grader, right? Don't use the calculator on this. Let's take a look at letter A. So the whole point is that we can think of 23 as 20 plus 3. The distributive property now says, well, I can do 7 times 20 and 7 times 3. Hopefully both of these are easier than this one. 7 times 20 is 140. 7 times 3 is 21, so I get 161. 7 times 23 is 161. Now I can do the same trick with 18. I could write it as 10 times 8. That would work fine. But subtraction also works with distribution. And the reason that subtraction works, by the way, is because remember, subtraction can be changed into addition of opposites. But we're going to leave it as subtraction. So 18 can be thought of as 20 minus 2. So now I can do 9 times 20. And I can do 9 times 2. 9 times 20 is 180. 9 times 2 is 18. Subtract, and I'll get 162. Coincidence that these two numbers are only 1 apart? Actually, yes, it is coincidence. I just sometimes randomly do that. So anyway, it's kind of neat, isn't it? I'm going to scrub this out. So write down what you need to. All right, it's gone. Now keep in mind, because this is very easy to become cynical or sarcastic about. You might look at this and go, I know the standard algorithm. I certainly know how to use my calculator. Why would I be doing this? Well, there's a couple of reasons. Number one, we're just trying to understand the distributive property. We're trying to understand how it works. And number two, let's face the facts. At some level, okay, now maybe it's just me, maybe I'm just a complete and utter math geek, I know I am, but at some level it's kind of cool. It's cool that you can do 9 times 18 and think of it as either 9 times 20 minus 2 or 9 times 10 plus 8, and you're going to get the same answer either way, all right? That is a neat property that multiplication and addition / subtraction have with one another, okay? So let's move on. All right, probably the hardest thing is using the distributive property twice. So let me show you how that's done. We're going to do 12 times 28, and we're going to evaluate it by thinking about the 12 as 10 plus 2, and thinking about the 28 as 20 plus 8. Now at first what I'm going to do is I'm going to treat this as one whole thing. In other words, I'm going to have 10 plus 2 times 20, and then I'm going to have 10 plus 2 times 8. All right, so I'm multiplying the 20 by 10 plus 2, and I'm multiplying the 8 by 10 plus 2. And yes, I know 10 plus 2 is 12. But now here's what's cool. I can now distribute these multiplications through these additions. So in other words, I can do 10 times 20 plus 2 times 20. Then I can do 10 times 8. And then I can do 2 times 8. And what do I get? Here, I'll get 200. Here, I'll get 40. Here, I'll get 80. And here, I'll get 8. 20 plus 40. Oh, sorry, not 20. 200 plus 40 plus 80 plus 8 gives me 300. Whoop. How did I get 8 there? That's just weird. Why didn't you say something? That's 16. Like, wait a second, that doesn't match my final answer. Let's try that again. And this couldn't have been more inefficient, could have been. All right, whew, that took a little while. All right, final answer of 336. So note to self, 2 times 8 is actually 16, not 8. All right, look at that double distribution though. I really want you to try to understand this. These both are what are known as binomials. Bi meaning 2. Binomials, all right? Binomial here, binomial there. We're going to be doing a lot of multiplication of binomials together when there's variables involved, and we'll be doing this double distribution a lot. Some teachers call it foiling, first, outer, inner, last, because you're multiplying the first terms together, that's this. Then you're multiplying outer terms together, that's actually this. Then you're multiplying inner terms together, those are these two. And then you're multiplying the last 2 terms together, which is the one I botched. Anyhow, I am going to clear out the text, so pause the video if you need to. Okay, here it goes. Wonderful. Let's go on to the next page. All right, so we can use the distributive property when it comes to purely numerical quantities, but we can also use the distributive property when we have variables in our expressions. So I'm going to walk through this very slowly at first and then pick up the pace. What I'd like you to do though is pause the video right now and see if you can remember how to do this from 8th grade and 7th grade math. Try to just do letters A and B, but if you're fast, you could do all 4 of them. All right, pause the video now and take as much time as you need. All right, it's important, by the way, early on in this course, when I give you a chance to try to remember something, or to simply try something out that maybe you've never done before, that you really give it your best shot. Sure, you can listen to me teach, you can certainly pick things up, but it's best if you can remember things on your own and figure things out on your own, right? It will make you a much better problem solver. So let's take a look. This says 5 times 2x plus 3. Now notice, I'm already thinking about this 2 times x as a single quantity. And what I really have is I've got 5 times 2x plus 5 times 3. Now, what do I do with that? Well, remember, multiplication is associative, meaning that I can actually do 5 times 2, then times x, and 5 times 3. That gives me permission to do 5 times 2 and get 10. There's really nothing I can do with that. I just have to leave it. 5 times 3 is 15, and that is the best I can do. Okay? Same thing with letter B. I'm going to do negative 4 times 5x minus negative 4 times 8. Oh, that looks confusing, doesn't it? Maybe I should do this. Maybe that helps. Maybe it doesn't. Again, using the associative property of multiplication, which allows me to group this multiplication together. No worries here. We'll just leave that as negative 4 times 8. All right, negative 4 times 5 is negative 20. Nothing I can do with the x. Here we're going to have negative 4 times negative 8, which is negative 32. And remember, when we subtract, we can replace with adding the opposite. So subtracting negative 32 is the same as adding positive 32. For a lot of people, they'll just see a double negative and immediately change it into a positive. That's okay too. Not a problem. All right, let's take a look at this one. This is a little bit confusing. This says we need to do x times x, and then we need to do x times 4. Well, we'll work with exponents a little bit more, but x times x is what is known as x squared. And then there's really nothing we can really do with that. Best we can do is write it down as 4x. Right? X times 4, 4 times x. All right, let's do one more. We'll have 5x times 2 minus 5x times 7x. All right, watch me use the associative and commutative properties of multiplication all at once. So I'm going to put the 5 times 2, And we'll bring that multiplication by x here. Watch this. Look at all this multiplication. We actually have four things, 5x, 7, and x. So I'm going to do the 5 times the 7 and x times x. Associative and commutative properties being used there. 5 times 2 is 10, x. 5 times 7 is 35. X times x is x squared. And that's it. Oh, my hand hurts after writing all that. Okay, I'd like you to pause the video now. Really think hard about this. This is a benchmark skill. You've got to be able to distribute through addition and subtraction. Okay? All right, I'm going to scrub out the text. Okay, it's gone. Now, one last little piece. Division distributes just like multiplication. And the reason for that is very simple. Division and multiplication are essentially the same thing. When I divide by 2, it's the same as multiplying by 1/2. When I divide by 7, it's the same as multiplying by 1/7. Watch out, I'm going to blow your mind. When I divide by 1/10, it's the same as multiplying by 10. Okay? So anything that multiplication can do, division can do as well. All right? So take a look. If I have b plus c and I divide by a, I can first divide b by a, c by a, and then add the results. Watch out. This is something that a lot of students make mistakes on. They think, well, I'll just divide the first thing by a because then I've done the division. But no, the division distributes over addition and subtraction, just like multiplication does. Okay? So let's get some practice on that. Express each of the following quotients as binomials in simplest form. Show your calculations. Some of your final answers will contain fractional coefficients. A coefficient is simply a number that multiplies a variable. Okay? So let's take a look. What the distributive property tells me is that I can take that division by 2 and I can divide 8x by 2 and I can divide 4 by 2. Further, I can actually do the associative property and I can first do 8 divided by 2, then multiply by x, and then do 4 divided by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. And my final answer is 4x plus 2. All right? Pause the video now and see if you can finish the last few. Watch out, letters C and D both involve fractions in your final answer, okay? All right, let's go through them. Letter B. All right, I can distribute that division by 5 through the subtraction. So 25x divided by 5 minus 50 divided by 5. Again, I'm going to use that associative property, which tells me I can do the division by 5 here first, then multiply by x. And we'll eventually do this division, but all in good time. 25 divided by 5 is 5. 50 divided by 5 is 10, so we get 5x minus 10. All right, now for some fractions. All right, same idea. I can distribute the division by 4 through that subtraction. All right, then I can rewrite this as 2 divided by 4 times x minus 16 divided by 4. Watch out, 2 divided by 4, it's tempting to say that's 2, but the numerator is smaller than the denominator, so I'm actually going to get 1/2 x minus 4. Good? All right, let's do this last one. This one's going to get the ugliest. Negative 9x divided by 12 plus 18 divided by 12. Again, negative 9 divided by 12 times x, 18 divided by 12. All right, let's have a little talk about reducing fractions really quick. So far, we've only had to reduce easy fractions, like 2/4 into 1/2. Negative 9/12, remember to reduce a fraction, what you'll do is you'll look for the biggest number that goes into both. That happens to be, in this case, 3. So negative 9/12 will end up being negative 9 divided by 3. 12 divided by 3 will be negative 3/4 x. Same deal with the 18 divided by 12. The biggest number that goes into both is 6, so divide by 6 on both, and we'll have 3 halves. So negative 3/4 x plus 3 halves. All right. So division distributes over addition and subtraction, just like multiplication does. All right, we'll see that quite a bit this year. All right, pause the video. I'm going to scrub out the text in a moment. All right, here we go. Excellent. Let's finish up the lesson. Okay, so in the last 2 lessons, we saw important properties of real numbers under addition, multiplication, division, and subtraction. We saw commutative properties, associative properties, and today we worked with the distributive property. All of these are going to be key in lessons that are to come. All right, so let me just thank you again for attending another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.